A very good day to everyone, ladies and gentlemen. Thank you for joining STAAD.Pro workshop. My name is Tang Jiaxian from IEMSS UTHM, and I will be responsible for hosting this program today. As we are about to begin, I hope that all participants will turn on the camera for a better interaction with our speaker and other participants. Next, I would like to remind everyone to make sure that your microphone is muted to minimize distraction from audio feedback. As a reminder to all of you, this workshop will be in a hands-on approach mode. Therefore, please turn on your microphone to voice the speaker any questions or concerns you may have during the section. Thank you. Ladies and gentlemen, as the moderator for this section, I'm so pleased to be with you today and have the chance to introduce our speaker, Engineer Dr. Zainal Rizwan bin Muhammad Jaini. Engineer Dr. Zainal Rizwan graduated from College University Technology Dom Hussein On in 2006 with a bachelor degree in civil engineering. He then completed his master in computer modeling and finite elements in engineering mechanics at Swansea University. In the year of 2013, he completed his PhD in civil engineering. Engineer Dr. Zainal Rizwan is a chartered member of European Association for Structural Dynamics (ESAD) for the term 2021-2022, and also the head of Structural Dynamics of Computational Engineering Focus Group. Engineer Dr. Zainal Rizwan bin Muhammad Jaini's past research was lightweight corrugated steel form concrete slabs, sandwich fiber camboard form concrete panels, fatigue failure of castellated steel beams, vibration of precast hollow slabs, infill reinforced concrete structures, multi-scale modeling of fibrous concrete, computational modeling of structures under impact and explosion, and last but not least is about damage and fracture modeling of reinforced concrete structures. Engineer Dr. Zainal Rizwan is also a fascinating person, and we are all in for a treat today. Without further ado, please welcome our honorable speaker for today, Engineer Dr. Zainal Rizwan bin Muhammad Jaini. The stage is yours now.
Thank you very much to the Mr. Chairman. First of all, I would like to thanks to the IEM student section UTHM for inviting me to deliver a sharing session on the STAAD.Pro workshop. So I would like to share my screen. Perhaps that the participant also have received the slide presentation that you may refer to the slide. Okay, so for this afternoon, I'm going to share and also demonstrate, okay, about the STAAD.Pro, how that we conduct the structure modeling and analysis using STAAD.Pro. So as introduced by Mr. Chairman, I'm actually the head of the focus group for the structure dynamic and computational engineering, in which that focus to the application and developments of the software and programming related to the structure engineering, especially in the civil engineering. So for the STAAD.Pro, okay, workshop this afternoon. So this is my outlines of the presentation. Okay, so we have around 3 hours to complete the workshop, in which that I have divided to the 3 parts. So part A is actually introduction to STAAD.Pro, and then we going to follow with the part B. This part will be the hands-on, in which that I will demonstrate how to conduct the structure modeling and analysis using STAAD.Pro. So we have 2 case study in this part. The first one related to the continuous beam, and the second one related to the indeterminate truss. I believe that the hands-on under part B is very important to the participant, especially those who are not have previously any knowledge about the STAAD.Pro. Okay, you're going to learn step by step how to conduct the modeling and analysis using STAAD.Pro. And the last part in my presentation this afternoon is a part C. So in this part, I will share with you advanced structural analysis using a finite element method. This is actually very interesting topic, under structural analysis. Hopefully that you will be stay with me until at the end of the session. Okay, so without further ado, I would like to continue with my presentation. So about the introductions of the STAAD.Pro. So basically a STAAD.Pro, okay, the word STAAD and Pro basically stand for the structural analysis and design for professional. Okay, so this is actually how the terminology or the terms of the STAAD.Pro come, okay, from the sentence of the structural analysis and design for professional. So based on the word professional, okay, so basically a STAAD.Pro required the certain extent of the knowledge in the structural analysis and design. Okay, so for a civil engineer, especially for student, understanding on the STAAD.Pro is very important. Without that, okay, you are not able to conduct the structural analysis and design using STAAD.Pro. So basically, STAAD.Pro is one of the powerful and robust software produced by Bentley System. So this software basically have been in the market since 2000 during my year as a student already. It's a very comprehensive software that address all aspects of the structural engineering, especially for the model development, analysis, design, visualization, verification, and so on. So I can say that the STAAD.Pro is actually one of the important software in the consultant for those who are working as a structural engineer or designer. This is actually the most software that widely applied by the engineer in terms of the structural analysis, structural design, doing the final element modeling, and so on. So basically, STAAD.Pro, okay, this software basically capable to guide user through various steps of the process. Among the process are the creating the input file, which is actually the modeling stage, either using the graphical or through the text editor. Nowadays, we have the good platform in the modelings of the structure using STAAD.Pro, which is actually using the direct interface in the STAAD.Pro. STAAD.Pro also provide running to perform the analysis and design, the running platform. Also visualization and verifications of the model graphically and numerically, in which that you can get the result after you finish the analysis. And also for the purpose of the reporting, you also may proceed for the printing the output result, okay, as your desire, especially in the preparing of the document, okay, for the summations of the for the project summations or for the any project tendering. So this is actually some of the so-called evolution in the STAAD.Pro. So basically, previous years, okay, we have the STAAD.Pro version 2007, and then after that, okay, we have the STAAD.Pro version V8i. Okay, so basically, the advanced engine provided by the STAAD.Pro, starting with the SS4, and then we have the STAAD.Pro version 8i, SS6. So this is actually the update version from SS4, which is actually include the new code of practice for the Eurocode. So basically, students who have learned about the design, you may familiar with the code of practice Eurocode, BSEN 1992, 1993, 1994, and so on. So under STAAD.Pro V8i SS6, so this code of practice already embedded on the STAAD.Pro. And since 2018, okay, we have actually the new versions of the STAAD.Pro, which is actually more powerful. Okay, so the new version has integrated between various software under Bentley system. Among that, actually the STAAD.Pro, and then we have the RCDC, we have the RAM connection for the designs of the steel connection, and then we have the Pro structure and so on. So the latest version, STAAD.Pro Connect version 22, come with the online version, which is actually required the subscription and the installations of the software through the so-called centered application and controlled by the Bentley system. So basically for today, I believe that you have you get the license, you get the installations of the STAAD.Pro, which is actually using STAAD.Pro version 8i V8i SS4. So this actually both SS4 and SS6 in terms of the modeling and analysis basically have no much differences. Okay, the only difference that the SS4 have included Eurocode, okay, for the design purpose. So we're going to use this software this afternoon for our case study. But don't worry, if you are looking for the STAAD.Pro Connect version 22, you have the opportunity to undergo the training using STAAD.Pro Connect version 22. Later on, I will share about the professional training, okay, that we provide, okay, for the student to enable you to explore about the latest versions of the STAAD.Pro Connect version 22. So this is actually the interface of the STAAD.Pro. So everything is a very comprehensive in the just one interface. Okay, so basically the interface of the STAAD.Pro consists of the following component. So at the top part here, if you can see, which is actually marked as a A. So this is actually what we call as the toolbar. Okay, so it's actually seems like our toolbar in the Microsoft Word. So this toolbar basically provide us with the few function, okay, for the purposes okay, that we're going to use for the definition of the structure and also assignments of the few specification that required in the modeling and analysis. And then at the left side, okay, here at the left side of the interface, okay, which is actually marked with the B. Okay, so here is actually the page control. Okay, the page control here actually provides, okay, the so-called a stage, okay, that we're going we need to actually go through part by part in order to conduct the modeling in analysis. From starting, we have the setup here, and then geometry, general analysis, and the last page control, which is actually the design. And then at the main parts of the interface, which is actually marked by a C here. So this is what we call as the main window. Here that we are going to use, okay, for the purpose of the developing our model, okay, from starting from the creating the node and then connecting the node to create the element and so on. And then at the right side here, okay, which is actually marked by the D, is actually the data area. Okay, data area actually provide us with a lot of information, okay, especially related to the specification, properties and so on, okay, during our process conducting the modeling and design. And then at the top part here, which is actually marked by E, so this is actually the top menu. So the top menu actually provide various function here, okay, that later on I will explain during our hands-on demonstration. Okay, every function at the top menu. And then at the end left sides of the interface marked by F, so this is our side menu. Side menu is very important because it's actually provide the function for our cursor in order to selecting the element. So later on, I will demonstrate how that we using the side menu in order to select the element. So this is actually a few important function. Okay, few important function under STAAD.Pro. Okay, we have the element cursor. So this is what we call the element cursor under F. This is actually side menu. Okay, and then we have the view and rotation. Okay, view and rotation here. Okay, located at the E. This is actually the top menu. Okay, and then we have a unit and level. Zoom and rendering also located at the top level. At the top menu. Okay, and then we have the create element. Okay, so this is actually very important function in the STAAD.Pro in order to us to create the element during our modelings of the structure. So from the left here, we have the insert beam. Okay, at beam, at plate, okay, at shell, at solid element, and so on. So create element also located at the top menu. Okay, and then we have another function for the constructions of the structure or for the constructions of building. Okay, so this important function called repeat and generate. Okay, so this function also located at the E. Okay, so if you can see here, most of the important function in the STAAD.Pro is actually located at the top menu. Okay, except for the element cursor, which is actually located at the side menu. Okay, so basically, if you are familiar with the interface and functions of the STAAD.Pro, okay, probably you have no problems to conduct the modeling and analysis of structure using STAAD.Pro. So in general, okay, the modeling and analysis of the STAAD.Pro, okay, we can divide into two stages. Okay, the first stage, what we call as the pre-processing, and the second stage is a post-processing. Okay, so basically the pre-processing include the modeling and half of the analysis procedure. Okay, so under modeling, this is actually where the platform that we're going to use to construct our model from the single structure to the 2D and 3D frame, including the building, and also we able to construct the final element modeling under the modeling platform. And then after that, the second platform under STAAD.Pro is actually analysis. So this analysis actually important for us to actually after the modeling, we must proceed with the analysis. They have actually a various type of the analysis that we can conduct under this platform. Among other is a linear or non-linear analysis, static or dynamic analysis. We also have the implicit or explicit analysis. So it's a depend on the our requirement in the analysis and design. We must accurately define one types of the analysis that we're going to conduct for the modeling and analysis of the structure. And then the last stage or the last platform in the STAAD.Pro is known as a design. So design actually under the post-processing. So it allows us to conduct the design for the reinforced concrete structure, for the structural steel, including the hot roll steel and cool form. And then we also have a composite structure. And then we also have another different structure including aluminium, stainless steel, and then a timber. Okay, timber design also can be conducted, okay, under STAAD.Pro. Okay, so the process of the modeling. Okay, so basically we have a few different procedure, okay, that need to be completed, okay, in order to conduct the modeling. So basically we started with the geometry, and then followed by assign the property, and then assign the specification, and then assign support, and then the last step, okay, under modeling is actually assign the load and definition. Okay, if we see in detail, okay, one by one, for the geometry, basically under the geometry, okay, if you can see at this at the interface, okay, under all the modeling, okay, basically located at the general, okay, under functions of general. So here, okay, they have the few button that we need to proceed one by one, starting with the geometry. So the geometry is actually the place where we need to set the coordinate and create the node, and then we must create the element, and then we connecting the element, or we connecting the node between element, and then after that, okay, we can complete the whole process, okay, to construct the structure or to construct the building in STAAD.Pro. After we finish with the geometry, we can proceed with the property. So property is actually the place where we assign the dimension and the material characteristics of the structure itself, in terms of the cross section, okay, in terms of the shape of the structure, okay, and then for the material characteristic, okay, we need to define the types of the material, okay, either it's a concrete, steel, aluminium, timber, or composite. And basically for the every single material, we need to actually specify the value of the Young modulus, Poisson ratio, density, strength parameter, and so on. So this is actually a part of the material properties, okay, that need to be defined on the structure or on the building. And then after that, okay, we need to define the specifications on the structure. Specification actually refer to the specific requirement that must be defined to the structure, especially for the structure that have the function for the compression tension, okay, like truss as example. Okay, we have the component of the truss that become compression, or we have the structure that act as the tension. So these kinds of the behavior, okay, must be defined on the structure using specification. Okay, and then we need to define support, okay, which is actually represent the boundary condition on the structure. So when we talk about the support, basically you may familiar with the pin, roller, and fix. So this is actually a parts of the boundary condition that we need to define, okay, on the STAAD.Pro. And then the last step, okay, under modeling is a create the load and define the load on the beam. Okay, so they have various types of the load that we can select. It depends on the nature of the structure itself and the external load that we're going to apply, okay, on the structure. Okay, so under the modeling, okay, this all step, okay, must be defined properly. Okay, if you miss one step here, or you forgot one step, okay, that will be affecting your analysis, okay, in which that you are not going able to run the model because your model now have the error, okay, due to the missings of the certain parameter in the modeling. Okay, so basically we can conduct the the constructions of the structure and building in STAAD.Pro using a few approach. Commonly, we have a two approach, either using a graphical method. Okay, the graphical method is the most easy. Okay, the most easy approach. Okay, that we can use. Okay, to construct the structure or to construct the building. So this is actually what we're going to have this afternoon. Okay, under part B. Okay, we going to use the graphical method in order to construct the building and to construct the structure. Alternatively, okay, we can use the text method. So this text method, however, required a good understanding in the programming. Okay, if you're very good handling the programming or program language, okay, you'll be able actually to understand about the STAAD.Pro editor. Okay, so it's actually I can say it's actually quite simple compared to the C++ or Python or Fortran. Okay, that have you maybe some of you have learned about this programming language. Okay, it's actually quite easy, but of course it's actually required certain extent of the knowledge, okay, to handle the commands in the STAAD.Pro editor. Okay, we move to the second the next platform, which is actually analysis. Okay, so analysis have a two stage, which is actually pre and post processing. Okay, under the pre-processing, okay, so we are required to define the analysis command, okay, in order to allow STAAD.Pro to conduct the analysis on our structure. So they have actually few different commands depend on our desire on the structure analysis, whether to analyze the structure as a linear, non-linear, as a direct analysis, as an imperfection analysis, as this one for the column, basically buckling analysis also for the compression member, and pushover analysis if you conduct the bridge analysis and design. And they have actually a few different other types of analysis that available in the STAAD.Pro. And then after that, okay, after we define the analysis command, okay, we need to define the print option, okay, on the STAAD.Pro. So the print option basically allow us to access, okay, the information about the load data, static check, static load, mode shape, and so on, and actually save the data, okay, on Microsoft Office. Okay, if you require such of the data, okay, you must provide the print option during the stage of the analysis. And then after you completing the both analysis command and print option, you can run the analysis under the functions of the run analysis. Okay, after you completing the analysis, okay, so this is actually we now are able to proceed with the post-processing. Okay, post-processing, which is actually the stage in which that you can view and collect the output data, or on the other word, it's actually the result of the analysis. Okay, you can also complete the report or produce the report if you are looking for the preparations of the report. But if you need to prepare the report, okay, there is actually another compulsory function that you must define, which is actually the setup report on the STAAD.Pro. Okay, so this is actually the example of the pre-processing, which is actually involve the constructions of the structure. So this is actually the roof of the SPRM Kuala Terengganu. Previous years in 2008, I was basically involved with the design of this project. Okay, so I'm using a STAAD.Pro in order to design, okay, the trusses and the roof system of the building. Okay, so the post-processing, okay, remember, is actually involve the geometry, property, specification, support, loading, and definition, and as well as, okay, the definitions of the command, analysis command, and also a print option. And then after that, okay, you can have the post-processing, in which that you can actually view the result. Okay, you can get lots of the result in terms of the reaction force, displacement, bending moment, reaction, shear force, stresses, um, torsion, and so on. Okay, so every single result will be available in the post processing. So this is actually the uh, the details of the uh, geometry of the structure or geometry of the building. So this is actually what you can visually, okay, get the result, okay, in terms of the bending moment. Okay, you can check, okay, part by parts of the structure, okay, how the diagram, okay, of the bending moment and shear force, okay, depending on what we are looking in terms of the result. And then, okay, the last part, okay, under post-processing actually involve the design. Okay, so unfortunately, this afternoon, we are not going to actually discuss about the design of the structure. Okay, we are mostly focused on the modeling and analysis of the structure only. Okay, so the designs of the structure is actually very complicated. Okay, it's actually required a good knowledge in the design and also a good knowledge in the STAAD.Pro itself. Okay, under the design, okay, we can actually organize the member, okay, define the groups of the member, define the brief or the specifications of the design according the code of practice. Okay, either we using the British standard, BSEN, Eurocode, or Malaysian standard, MSEN, or other different code of practice. Okay, in the design stage, okay, we can get the member design and result visually. Okay, we can see the results of the design for the reinforcement, for the reinforced concrete structure. We'll be able to know about the reinforcement. For the steel structure, we'll be able to go through every detail of the design process in terms of the checking of the structure and the safety of the structure. And then you can actually get the, you can produce the drawing or layouts of the structure in terms of detailing especially, and then provide the report. Then you can also export, okay, the layout, okay, to the AutoCAD using the DSF file. Okay, so this is actually three different stages, okay, in the STAAD.Pro, okay, involving the pre and post processing. Okay, so basically STAAD.Pro is a very comprehensive software, okay, which is actually involve, okay, a lot of function in structural engineering. Okay, so that this afternoon, within 3 hours, we are not able to cover everything, but perhaps that, okay, we're going actually to understand about the process of the modeling and analysis of the structure using STAAD.Pro. So basically, they have a few different types of analysis and design and STAAD.Pro. So basically, a STAAD.Pro provide a basic analysis and dynamic analysis. For the basic analysis, we have the primary, P delta, non-iterative, non-linear, truss analysis, cable analysis, and so on. So this is actually under the basic analysis. If you want to going further, okay, related to the dynamic analysis, in terms of the Rayleigh agent solution, time history of the dynamic for the impact and explosion, seismic, okay, you can use the dynamic analysis under STAAD.Pro. You also will be able to get the response spectrum, okay, for the flow, if you are looking for the vibration analysis. Okay, and they have actually another types of the dynamic analysis available in the STAAD.Pro. In terms of design, STAAD.Pro also provide a basic design and a special design. Basic design basically involve the designs of the reinforced concrete structure and structural steel, okay, for the beam, slab, column, truss, foundation, and so on. For the special design, okay, we have the bridge design, seismic design, okay, for the and then we have the aluminium structural design, timber structural design, composite structural design, transmission tower design, and so on. So this is actually need to be conducted under special design using STAAD.Pro. Okay, so basically, STAAD.Pro use a final element method to perform the analysis. Okay, I believe for students who have already learned about the structure analysis, okay, you can see here that they have a lot types of the technique of the structure analysis that basically we provide as we divided as the quantitative method and qualitative method. Okay, so basically we have the equilibrium of the state for the joint method and Euler method. Okay, we have the energy method. Okay, so this is actually specifically for the ritual walk method and C theorem. Okay, we have the force method for the influence line. Okay, for the influence line, flexibility method, and Maxwell theorem. Okay, so all these are three techniques under force method. And then we have a different method under a quantitative method. So a different method basically can be further divided as the slope deflection method, moment distribution method, and direct stiffness method. Okay, other method under qualitative is actually a plastic method and the Muller-Breslau, and which is actually we're using for the influent line under moving load. Okay, since the STAAD.Pro using a finite element method, okay, so if you learn about the direct stiffness method and the displacement method, so this is actually what we call as the basic to finite element method. Okay, direct stiffness method. So both direct stiffness method and also another different technique in finite element, okay, have been abandoned in the STAAD.Pro for the purpose of the analysis. Okay, theoretically, okay, you have learned moment distribution method and slope deflection method to analysis the continuous beam. Okay, you also have learned about the joint method and also energy method. Okay, visual work method for the trusses. Okay, so this afternoon, okay, we going to compare the result, okay, that we obtained from the STAAD.Pro with this with the other available classical method, okay, in the structural analysis. Okay, so
Dr. Saino, sorry to interrupt you. Just to remind you that there is still 5 minutes left for this section.
Okay.
Part A.
Okay, thank you. Okay, okay, for the principle of the analysis, so basically a STAAD.Pro provide a few important platform, okay, that we can use, okay, for the purpose of the modeling. So basically we have the space, which is actually in the 3-dimensional model. We have the plane in the 2-dimensional model. We have the truss, which is actually a 2-dimensional model for the truss structure. And then we have the flow, okay, which is actually provide us a 2-dimensional and 3-dimensional structure for the floor system. So this is actually the what we call the mode, okay, on the STAAD.Pro that we need to select at the first step, okay, when we conduct the modeling in the STAAD.Pro, okay, in order to specify, okay, the function of the structure that we're going to construct. So basically the application, okay, of the STAAD.Pro, okay, mainly we use for the structural analysis structure design, numerical modeling, which is actually using a finite element method. We also use the STAAD.Pro for the forensic engineering. Okay, as you can see here, okay, for the structure analysis, basically, besides the STAAD.Pro, we have another alternative, which is actually par with the STAAD.Pro, SAP 2000 and Robot Autodesk. For the forensic engineering, we have another alternative software that we can use. Okay, among other CSI Safe, Midas, RISA. Okay, for the forensic engineering. For the numerical modeling, okay, the advanced software, okay, compared to STAAD.Pro is analysis, ANSYS, Abacus, and Elephant. Meanwhile, for the structural design, which is actually advanced software compared to the STAAD.Pro, among others, Tekla, ETAP, and Esteem. Okay, so even though STAAD.Pro integrated all these four types of the application, from the structure analysis to the structure design, to the numerical modeling and forensic engineering. But of course, they have the pro and con, okay, using STAAD.Pro. So they have the advantage and disadvantage using the STAAD.Pro that we must identify and understand, okay, before we proceed with the certain types of the project. So this is the application among the applications of the STAAD.Pro, from the modelings of the single structure, okay, to the designs of the multi-story building. Okay, you can see here we have the section, I section beam. We have the we can analyze the base plate. We also can analyze the circular plate on the STAAD.Pro, and also conducting the analysis and design of the multi-story building. Okay, we also can conduct the analysis and design, okay, for the bridges. Okay, so you can see the rendering view of the bridge here, and then this is actually the results of the analysis of the bridge. Okay, so this is actually a advanced application in the STAAD.Pro. Okay, so this is actually the procedure of the analysis and design. Okay, we start with the pre-processing in terms of the constructing and developing the model on the STAAD.Pro. So this is actually the step-by-step procedure that you need to follow. And then after that, for the post-processing, okay, we have the run analysis, and then, okay, you can check the post-processing results, okay, and the post-processing. So this is the step, okay, that need to be followed. And then after that, okay, for the design procedure, so this is actually the, okay, the step-by-steps, okay, and the post-processing to conduct the design of the structure or designs of the building. I'm not going to explain in detail about the procedure, because later on in the part B, okay, you're going to experience, okay, every single step, okay, and the pre-processing and post-processing. So I think that's all, okay, for the part A, okay, which is actually the introduction, okay, to the STAAD.Pro. Okay, I may open a few questions if you have before we proceed with the part B. Okay, so under part B, we're going to conduct hands-on modeling and analysis of design for the continuous beam and the indeterminate truss. Okay, before we proceed with the part B, I may open a Q&A, okay, if you have related to the introductions of the STAAD.Pro. Okay, any question? Okay, if we have no question, so I think we proceed with the part B. Okay, part B is actually the hands-on case study. Okay, we have two different case study. okay, for the modeling and analysis of the structure. Okay, so this is actually just a basic modeling, okay, for the simple structure only. First, we have the case study one, okay, related to the continuous beam. And then after that, okay, we're going to conduct, okay, the modeling and analysis for the case study two related to the indeterminate truss system. Okay, for the case study one, okay, we need to consider a continuous beam, okay, subjected to the uniform distributed endpoint load, okay, in which that, okay, the continuous beam have a size 300 mm times 500 mm with the strength of the concrete at 27 megapascal. Okay, so this model of the continuous beam, so basically I'm take from the structure analysis model, structure analysis module, example 4.4, page 20. Okay, I think I don't know if you are using this note, okay, during your study on structure analysis. Okay, so this is example 4.4, okay, in the structure analysis module. Okay, so this have been solved using a moment distribution method. Okay, but today we're going to use the stiffness method or final element method, okay, under STAAD.Pro in order to solve the problem, okay, to determine the shear force and bending moment. Okay. Okay, so basically, I'm also have provide, okay, a note, okay, that explain a step by step, a similar step, okay, that I'm going to share with you this afternoon. Okay, you can actually later on, okay, doing another revision, okay, on this case study one, okay, which is actually about the modeling and analysis of the continuous beam. Okay, okay, what we need to do, if you have already installed the STAAD.Pro, okay, I will explain the process of the modeling and analysis in STAAD.Pro step by step. Okay, you may follow, okay, the step with me, okay, and if you have the problem or issue related, okay, the process of the modeling and analysis, okay, you can ask any question, okay, during okay, during the modeling process later on. Okay, okay, so here, okay, we have a three span of the continuous beam, okay, span A, B, span B, C, and also span cantilever, okay. So this, let's see, we consider as a span CD here, okay. In STAAD.Pro, okay, if you have read about the procedure of the modeling, okay, what we need to do now is actually to create the node, okay, on the STAAD.Pro, okay. So the node, okay, we must have a clear strategies in the modeling of the structure, okay. If you want to create the node, okay, we must have the reference of the node. Okay, so basically, okay, we can use, okay, the point, okay, at the A here as our reference. Okay, at the point at the A, okay, will become the reference, coordinate reference, okay, in order to create the first node in our model. Okay, so this one will be 0, 0, 0 coordinate. Okay, because we conduct, okay, the modeling process in 3 dimension. Okay, so if you have the STAAD.Pro, okay, we can start open the STAAD.Pro now. Okay, so I have STAAD.Pro V8i SS6, okay, which is actually the what we call the icon here. Somehow have the green color. Okay. If you install the STAAD.Pro V8i SS4, okay, so the icon have the blue and red color. So show a different versions of the STAAD.Pro. Okay, even though okay your version is actually different with me. Okay, you are using SS4, I'm using SS6, but okay, all function basically similar. Okay, so what we need to do, okay, before we start the model in STAAD.Pro, you must actually create the folder on desktop. Okay, here I have already created the folder and I'm rename the folder as a 000 IEM-SSS. So you can just have any kinds of the name, doesn't matter. If you put a 000, okay, the reason I put 000 here because I want to have this folder located at the top list of my list of the folder in STAAD.Pro. Okay, so this is the reason why I put a 000. Okay, so if you have the if you have already the folder, okay, so we can start the STAAD.Pro now. You just need a double click STAAD.Pro icon, okay, on your desktop, okay, and the first interface of the STAAD.Pro will be appear. Okay, so this is actually the dialog box. Okay, depending on your screen resolution. Okay, uh, basically, they will actually recommend, okay, either to proceed with the current resolution or not. Okay, so somehow doesn't matter what is actually the resolutions of your screen, as long as you have the minimum recommendation. Okay, this is okay. Okay, we just click yes. Okay, if you click yes, then it will be directing you to the main interface of the STAAD.Pro. Okay, so this is actually the STAAD.Pro V8i. Okay, if you can see here, so this is the select series 6 or SS6. Perhaps that you have the STAAD.Pro V8i select series 4 or SS4. Okay, but doesn't matter. It's actually a same. Okay. Here, what you need to do, actually, you must check your lesson configuration. Okay, basically, we are using a advanced analysis engine. Okay, so you must make sure, okay, that the lesson configuration must be ticked and have the green color indication, which is actually means that, okay, you have the permission, okay, to use the license for the advanced analysis engine. Okay, otherwise, okay, you may need to take the necessary step, okay, in order to activate the license configuration. Okay, and then after that, okay, you can go to the for the first time, okay, if you are using the STAAD.Pro, you can go to the configuration. Okay, just click the configuration. Here, okay, they have a few function, okay, that can be selected. Okay, especially, okay, you must choose the base unit, okay, in the modeling using metric. Okay, so if you are using English unit, you must change to the metric unit. So this is very important. Okay, otherwise that, okay, you are not able to use the correct unit, okay, in the structural modeling. Okay, the rest of the function, okay, no need to be changed. But if you want to change like so-called code of practice, okay, from American to the British, okay, you can just simply change here. Okay, as example, if you are familiar with the British code of practice, okay, then you can just select, okay, the default, okay, of the code of practice using a British standard. Okay, in terms of the background color, you can change to have a white background or black background. Okay. Similar for the design code. Okay, you can change from the American standard to a different code of practice. Okay. Otherwise, we can change later on. Okay, during the main interface. Okay. Here, okay, the most important basically to check the base unit. Okay. Make sure you are using metric. Okay, so then you can just click accept and apply. Okay, so this is the important configuration, okay, that need to be performed before we start with the modeling. Okay, okay, the rest, okay, no need to uh, you can explore later on about the backup management and the license management, but this is not really important, okay, for the settings of the modeling in the STAAD.Pro. Okay, for the new project, okay, we just click a new project. Okay, here, okay, they have the dialog box for the new project, in which that give us a few selection of the mode of the modeling mode in the STAAD.Pro. Okay, in my slide, okay, I have a description about the space, plane, flow, and truss. Okay, so basically, if you are going to conduct the modeling in 3 dimensions, okay, you must select space. Okay, for the plane is actually for the 2 dimension. Flow is actually either 2 or 3 dimension for the flow system only. And the truss basically for the 2 dimension truss system only. Okay, but I'm recommend you, okay, for any model of the structure, okay, better to use a space, okay, in the 3 dimension. Okay, so this is actually a better selection, okay, in order to conduct the modeling and analysis of the structure in the STAAD.Pro. Okay, and then you can just rename the file name. Okay, let's see, I have here as a case study 1. Okay, and then select the folder, okay, the locations of the folder, because I already have the folder on my desktop in which that I put the name as the 000 IEMSS. Okay, so this is actually the reason why I put 000, because it will actually list the folder at the top of the list. Okay, so I'm actually select this folder. Okay, make sure that, okay, you take the proper length unit and force unit in meter and kilonewton. Okay, if you already use the metric as a default unit system, so it will be automatically tick, okay, meter and kilonewton. And then the next, okay, you just click next. Okay, this one, okay, no need to change. Okay, we going to have add beam, okay, as our main function in our model. Okay, and then just click finish. Okay, if you are already click finish, so it will be bring you to the main interface of the STAAD.Pro. Okay, so this is actually the main interface. Okay, we have the graphical method, okay, to conduct the model. So this is actually, okay, the place, okay, where, okay, we're going to use, okay, for the graphical method. Okay, we have the here, okay, at the right hand side. So this is our working data. Okay, otherwise, okay, you can click, okay, you can click at the stat editor here. Okay, and proceed with the conducting, okay, the modeling using a command programming. Okay, but this one may be quite difficult if you are not familiar with the programming. So the best, okay, option, okay, in order to conduct the modeling and analysis using STAAD.Pro is actually using the visual method. Okay, so okay, so if you click, okay, okay, at the main, okay, at the main interface here, so it will be activated, okay, the function at the top and the left side of the interface. Okay, so you just need to click, okay, at the any, okay, point on the interface of the STAAD.Pro. Okay, so here, okay, this is our model. Okay, the first step, okay, that we need to do is actually to define our reference coordinate. Okay, our reference coordinate. So this reference coordinate represent node number 1. So this one become node number 1. And then we're going to have a node number 2, and then node number 3, and then the last is a node number 4. Okay, node number 4. Okay, so this is actually 4 nodes, okay, that we need to create first, and then after that we're going to connecting the node in order to create the complete beam. Okay, so for the first node, okay, with reference, as a reference with a coordinate 0, 0, okay, what we need to do here is just, okay, put 0, okay, here at this side. Okay, you just need to put 0 and then enter. Okay, click enter. Okay, so you can see here, so this is our first node in STAAD.Pro. Okay, so this is our first node in STAAD.Pro here, this one. Okay, so if you want to activate, okay, the number of node, okay, because, okay, here we have the number 1. Okay, this one is a node number 1. Okay, we are okay, so we are going to actually have a similar number, node number 1. So to activate the node number, what you need to do is actually go to the symbol and level here. Okay, go to the symbol and level, and then you can tick node number and node point. Okay, take both, okay, node numbers and node points, and then click OK. So now you have the number of node. Okay, you can see. Okay, so this is actually a number of node. Okay, node number 1. Okay. Okay, so now, okay, what we need to do is actually utilize the copy and paste function in STAAD.Pro. Okay, it is actually easy. Copy and paste node number 1. Okay, to create node number 2. Okay, we copy node number 1 and then paste the node to create node number 2. Okay, similar with node number 3 and node number 4. Okay, for node number 3, okay, we're going to copy node number 2, copy and paste. And then for node number 4, same, we're going to copy node number 3, copy and paste in order to create node number 4. Okay, so this is actually what I'm really so-called happy with the STAAD.Pro, is that it STAAD.Pro provide us with the source of the function copy and paste. Okay, so how to copy? Okay, you can use a Control C, Control V. Otherwise, you can just click on the right side of your mouse. Okay, if you click, you have the copy, right? Cut, copy, and paste here. Okay, so in order to copy the note, you must select the note. Okay, so in order to select the note, we must using the right cursor here. Okay, so this side, okay, is the cursor of the element. Okay, every element note, okay, beam, plate, shell, solid element, okay, must be selected using their cursor. As example, for note, you must use a note cursor. For beam, you must use a beam cursor. For plate, you must use a plate cursor. Okay, otherwise, okay, it will be not selected. The element, the node or element will be not selected. Okay, if you are using a wrong cursor. Okay, so this is a node. So I need to click to the node cursor, and then I can select the node. Okay, so it now highlighted with the red color, which means the node already selected. Okay, so you can use Control C or Control C, Control V for the copy and paste function. Otherwise, okay, just using the right sides of the mouse, okay, copy, and then again paste node. Okay, so now we have the dialog box. Okay, ask you, okay, a distance, okay, a distance that need, okay, to be specified, okay, for the node. Okay, so here, okay, this is actually our main axis. Okay, we have Y in vertical direction, and we have the X and Y direction in the horizontal direction. Okay, we're going to copy, okay, the node in X direction. Okay, but this is up to you. Okay, you can model the beam at X direction or Z direction, doesn't matter. Okay, so in this case, okay, I'm going to copy the first node in X direction. So with specifications of the distance 6 meter. Okay, from A to B, we have a 6 meter. Okay, so we just put here in X, okay, 6 meter. Okay, and then click OK. Okay, now we have our second node. Okay, in order to create, okay, the third node, okay, node number 3, okay, we copy node number 2 at X direction with distance 4 meter. Okay, so again, select node number 2, okay, Control C, Control V, or using the right side mouse. Okay, so specify the distance of the node 4 meter, and then, okay, you have a third node. Okay, for the fourth node, okay, we need to copy node number 3, node 3, okay, and then paste in X direction with distance 2 meter. Okay, so select node number 3, okay, using a copy, and paste node, okay, in X direction 2 meter. Okay, so now, okay, we are completely have the 4 nodes, okay, in our model. Okay, represent, okay, node number 1, okay, for the support A, node number 2 for the support B, node number 3 for the support C, and then we have the last node, okay, that represent the end beam without support. Okay, so if you want to see this model, okay, in 2 dimension, because now it's in 3 dimension, okay, you can actually change, okay, change the view, okay, either from view front, side, no, back side, okay, left side, right side, okay, plane view, okay, and then or in the isometric view. So this is actually the function, okay, or the icon that you can change, that you can use, okay, to change the view of the model. Okay, for the better, okay, better visualization, okay, I'm changed from the isometric view, which is actually 3 dimension, okay, to the view from Z. Okay, if you click, okay, if you click the view from the Z, so here it will give you, okay, the visual, okay, or the diagram, okay, of the model, okay, in 2 dimension, okay, represent X axis and Y axis only. Okay, so this is actually much better representation of the beam, okay, of the beam in the 2 dimension model. Okay, okay, anybody have finished, okay, the models of the node? Okay, so maybe how many of you, okay, follow, join me conducting the model in STAAD.Pro? Okay, you can raise your hand, okay, so that I can identify how many students that actually follow or conducting the modeling with me this afternoon. Okay, you may ask any question, okay, if you have the problem, okay, related to the model. Okay, okay, so if everything, okay, if you already have the node, okay, what we need to do now is actually to connecting the node, okay, to connecting the node in order to create the beam. Okay, so for this purpose, okay, okay, we need to use add beam. Okay, so add beams actually a function, okay, to create beam, column, okay, truss member, or any member, plane member, okay, that have a dimension as a structure. Okay, so although, okay, the icon is a name at beams, but basically we can use, okay, for the column, for the truss, or for any kinds of the structure. Okay, at beam is actually just a specific function, okay, that being used by STAAD.Pro. Okay, so we just need to click at beams, okay, and then we connecting, okay, the node, okay, using add beam, okay, by click the node number 1, okay, you can see here node number 1, and then go to the node number 2. Okay, so this is our first span AB, okay, span AB, and then, okay, we click node number 2, go to the node number 3, we have another span represent span BC, and then the last is actually the cantilever, okay, from node number 3 to the node number 4. Okay, so here, okay, if you want to select the beam, okay, you must using the beam cursor. Okay, if you drag, okay, the cursor, it will be selecting the beam elements. Okay, so this is actually our beam element. Okay, so if using the node cursor, if you drag the node cursor, it will be only selecting the node. Okay, so this is actually our first stage. Okay, if you realize it's actually under geometry. under geometry here. Okay, so this is actually the first step of the pre-processing, okay, which is actually create, okay, the structure, okay, or create the geometry, okay, of the structure or geometry of the building. Okay, so we already finished, okay, our geometry. Now we need to move to another platform under pre-processing, which is actually known as a general. Okay, if you click at the general, okay, so you can see, okay, they have a different function, okay, under general platform. Okay, which is actually starting with the top here is a property, and then spec, support, load and definition, and material. Okay, so this is actually, okay, the important step, okay, that must be conducting in order, okay, to properly model the structure. We must define the property. Remember, the functions of the property is actually to assign the dimension of the structure and also the material of the structure. The specification, okay, to assign the particular requirement or special characteristic on the structure, especially for the compression tension member, truss member. If we have the truss, okay, we can actually define, okay, the specific functions of the truss on the truss, okay, using spec. Support, okay, to define the support on the structure or the boundary condition on the structure. Okay, basically we have the fixed support, pin support, or roller support, depend on the boundary conditions of the structure itself. And then we have the load and definition. So this is actually to define and assign the load on the structure. Okay, the last part here is a material. So under material, okay, if you click material, okay, you can see, okay, we have two different properties of material, isotropic or orthotropic. Okay, isotropic is actually for the homogeneous material properties, basically for the steel, aluminium, and concrete. For the orthotropic, basically for the composite material or composite structure. So basically for the isotropic, okay, they have the default or library, okay, that already been created in STAAD.Pro. As example, concrete. Okay, if you double click concrete, okay, so this is actually the material properties that already been provided for the concrete grade, or for the concrete with the compressive strength 27 megapascal. Okay, but if we have a different, okay, different strength of the concrete, okay, you can just create, okay, the material, as long as it's a isotropic material. Okay, you can create, give name or title, okay, and then input the value of the material properties and design properties of the material, okay, under this dialog box. Okay, otherwise for the steel and concrete, okay, we can just directly use the default value, okay, if the properties is similar. Okay, so first, okay, we need to start with the property. Okay, so here is a given the size of the beam 300 mm times 500 mm. Okay, 300 mm times 500 mm. So how to define, okay, the dimension? Under property, okay, under property, go to the define. Okay, go to the define. Okay, now, okay, we can select the rectangle because the beam have the size 300 times 500. Okay, so 300 is the width, represent ZD. 500 is the depth or thickness of the beam, represent YD. Okay, so here, okay, YD in meter, so that we can just input 0.5 and ZD, okay, 0.3. Okay, so this is actually the dimensions of the beam. And the material, okay, so basically it will be default as a concrete, but you can change if you want to change to the steel, stainless or aluminium. Okay, but the default material given is a concrete. Okay, so this one, okay, no need to change. Okay, and then we just click add and close. Okay, so here, okay, you can see at the properties whole structure, okay, you can see we have the first size of the beam, okay, with the reference number 1, section rectangular 0.5 times 0.3, material concrete. Okay, so this data will be marked as a R1, represent reference 1. Okay, so how to define the size of the beam and the material of the beam on the structure? Okay, what we need to do, make sure that we are selecting the beam using the beam cursor. So you just need to select the beam. Okay, select the beam, or you can select one by one and then press a control. Okay, or just select. Okay, and then okay, make sure that here add sign to selected beam, you tick at the add sign to selected beam. Okay, and then click add sign, then yes. Okay, now okay, you can see okay on the structure on the beam, okay, the beam already marked with R1. Okay, R1 here represent reference 1 for the section rectangular 0.5 times 0.3 with a material concrete. Okay, so okay, if you want to check whether the section is correct or not, okay, we can render okay the structure to see the actual conditions of the structure. Okay, so here, okay, you can see here, this is the icon, okay, with the pyramid. Okay, so represent the 3D render view. Okay, if you click, okay, if you click a 3D render view here, so it gives you this is a okay rendering view of the beam in 3 dimension. Okay, so this is our beam, okay, with size okay 300 times 500 mm. Okay, so this is the okay that you can see okay from the rendering. Otherwise, okay, you can also okay change the model view detail. Sorry, you can change at the okay, you can change at the okay using your left right side right sides of your mouse. Okay, go to the structure diagram. Okay, here okay you can have a 3 section. Either now okay our structure have none 3D section, but if you want to see the if you want to conduct the modeling in 3D section, you can just select either to use a full sections or the section outline. If using a full section, okay, apply and okay, so this is actually what you can get on your interface. Okay, okay, so this is actually much difficult okay to handle. Okay, so that's why I prefer to use a non 3D section. Okay, so this is actually give the idealizations of the structure okay in just a simple in just a simple view okay for the modeling of the structure. But if you want to see the real okay, you can just render okay the structure. Okay, this actually will give you a much better understanding okay about the conditions of the structure. Okay, so we have done with the property. Okay, and for the beam here, okay, they have no specification that need to be defined because it's just a beam. Okay, so we just leave it the specification and go to the support. Okay, you can go to the support now. Okay, here, okay, we have the pin support, okay, at node number 1, and then we have another 2 support roller at node 2 and 3. Okay, so we must have a 2 type of the support, pin and roller. Okay, so how to define the support? Okay, under support, okay, and then go to the crate. Okay, go to the crate, and then you can select the appropriate support, okay, for your structure. So they have a lot of the type of the support. We have the fixed pin, fixed butt, and force butt, multilinear spring, foundation, incline support, and tension compression only spring. So this is actually a few different type of the support that can be used, okay, for the modeling of the structure. Okay, our beam, okay, have the pin and roller support. Okay, for the pin support, okay, go to the pin. Okay, so this is the pin support. No need to do with the restraint, just click add. Okay, if you click add, you can see here support number 2 with reference S2. So this is represent the pin support. Okay, for the roller, okay, we need to click create. Okay, for roller, okay, you can see here they have no roller. So for roller, okay, what we need to choose is a fixed butt. Okay, choose a fixed butt. Okay, and tick release for the all except FY. Okay, so okay, because okay, in Y direction, okay, in Y direction, okay, the node 2 and 3 must not move. Okay, okay, the node 3 can move in X direction. It can move in X direction. It can move in Z direction. Okay, it have a free moment in all direction. Okay, but in Y direction, okay, node 2 and 3, okay, cannot move, okay, in Y direction. So here, okay, for these types of the roller under fixed butt, again, what you need to do under release, select all except FY. Okay, so means that, okay, represent the roller. Okay, roller with the constraint in Y direction. Okay, so you just need to click add, and then, okay, automatically at the support whole structure here, okay, you have the support 3 represent our reference S3 for the roller. Okay, how to define on the node? Okay, first, okay, we select the support 2 represent the pin. Okay, click at the support 2, and then we need to select the node. Okay, node number 1. Okay, node number 1, and then make sure that, okay, it is a tick at the add sign to selected node, and then click add sign. Yes. Okay, now you can see that node number 1, okay, already been assigned with a support number 2, okay, which is actually pin. Okay, so here, okay, the diagram of the support represent pin. Okay, for node number 2 and number 3 is a roller, okay, represent by support 3. Okay, we just click support 3, and then we select node number 2 and number 3. Okay, make sure tick add sign to selected node, and then click add sign and yes. Okay, so here, okay, you can see, so this is actually the diagram or representations of the roller, okay, green color, okay. Okay, so in terms of support, okay, we have done. Okay, now, okay, we need to move, okay, to model the load and definition. Okay, we started, okay, again, we started with the property and then spec. Okay, under spec, we have no specification that need to be defined to our beam. Okay, so we just straightforward go to the support. Now we move to the load and definition. Okay, under load and definition, so this one you must be careful. Okay, because the procedure to define the load and definition actually quite complicated, and they have actually a few techniques, okay, that must be understand in terms of the load and definition. Okay, so here, okay, under load and definition at the right hand side here, your interface, okay, you can see, so the load definition, they have a three platform, okay, or three part, okay, that can be actually, you can expand, okay, in terms of the definition, in terms of the load case details, in terms of the load envelope. Okay, if you have a special analysis, okay, the load is actually either vehicle load, okay, time history, wind load, snow load, seismic load, or you are conducting the pushover or direct analysis, you must provide the proper definitions of the load, okay, using the stated function under definition. Okay, in our case, okay, we just have a basic analysis only, okay, for our beam, so no need, okay, to define, okay, any function under definition. Okay, we can go straightforward to the load case detail. Okay, so load case detail provide, okay, the number of load, okay, that we can actually differentiate, okay, in our structure. So in our case, okay, we can just have a one load case detail. Okay, no need to have a different number of the load case detail. But if you conduct the design, okay, for those who already study about the structure design or reinforced concrete design or steel structure design, you 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 understand that, okay, in the load we have the characteristic in terms of the variable action and permanent action. So this is actually a two different load cases, okay, that must be properly defined on the STAAD.Pro. Okay, if you are conducting the design, okay, you must define the proper load case on the structure itself. But in our case, okay, we are not proceed with the design, okay, so that, okay, to have just one load case is enough. Okay, to have just one load case is actually enough, okay, for our model. Okay, so click at the load case detail. Okay, click at the load case detail and then go to the add. Okay, go to the add. Okay, now, okay, you can specify, okay, the load case. Okay, so, okay, we just have the one number load case. So here is number one. So the loading type, okay, we can just select none. Okay, otherwise, if you are deal with the design, you must specify the loading type. Okay, from the dead load, live load, wind load, seismic load, snow load, soil, you have the traffic load, temperature, imperfection, and so on. Okay, so this is actually the detail of the load type depend on the nature of the loading. But in our case, okay, we just use none. Okay, because we are not specify any loading type. Okay, because our load, okay, just based on the uniform distributed or point load only. Okay, so here title, you can put any title as long as you can recognize, okay, that title is actually for the that particular load. Okay, I just use the default here, load case 1. Okay, and then click add and close. Okay, you can see here under load case detail, okay, they have already, okay, another function for the load case 1. Okay, so now, okay, we can define, okay, the particular load, okay, in terms of the uniform distribution, 10 kilonewton at the span BC and CD, and then we have the point load, 10 kilonewton, 20 kilonewton, 40 kilonewton, and another 20 kilonewton. Okay, so how to define the load? Okay, what we need to do is click at the load case 1. You must click at the load case 1. Okay, click at the load case 1 and then go to the add. Yeah, go to the add. Now, okay, the dialog box for the load item will be appear. So this is actually the load item. So you can see here they have a lot number of the types of the load, from self-wake, nodal load, member load, area load, flow load, plate load, surface temperature, seismic time history, wind load, response spectrum, repeated load, and frequency. Okay, so this is actually a common load, okay, that we have in the structural analysis. Okay, so our load is a uniform distributed 10 kilonewton, and then we have the point load here. Okay, first what we need to do is actually define the self-wakes of the beam. Okay, without the self-wake, okay, your analysis, okay, will actually experience error. Okay, so this is a compulsory load, okay, that must be included in all analysis. Okay, remember, okay, all structure have the self-wake, okay, and must be included in the analysis. Okay, for the self-wake, okay, you just click self-wake and then select self-wake. Okay, so here direction in Y, factor is a -1 because it's actually downward direction. Okay, downward, okay, direction in Y. Okay, in Y direction. Okay, so you just click add. Okay, you can see here, okay, at the load and definition, we have a self-wake. Okay, and then after that, okay, for the uniform distributed load, okay, for the uniform distributed load, okay, we must use member load. Okay, if you click member load, okay, it will be expand. The member load here will be expand. Okay, and then you have a few different types of the member load. Okay, from the uniform force, uniform moment, concentrated force, and you have a trapezoidal. Okay, you can check one by one. Okay, as example, trapezoidal, if you have the trapezoidal load, okay, if you have the hydrostatic, okay, if you deal with the soil interaction with the structure, okay, in which that include the hydrostatic pressure, you can use the hydrostatic. Okay, if you are dealing with the precast structure, in which that you need to define the pre and post stress, okay, you can just use the pre and post stress loading. Okay, for the uniform distributed load, is a clearly, okay, we need to use the uniform force. Okay, using the uniform force. Okay, so the value W1 here, okay, is a 10 kilonewton, negative 10 kilonewton. Okay, negative 10 kilonewton. Why negative? Because negative represent the magnitude and directions of the load. Okay, downward. Okay, so that's why we must put negative. If you put the positive, okay, the directions of the load is a upward. Okay, So D1, D2, and DT basically the distance or the length of the load. Okay, basically, if you have the load, okay, at the certain length, as example here, okay, from here to here. So this is actually the D. Okay, the D that you must define, okay, on this box. Okay, so D1 represent the distance from the support, D2 the length of the force, and then D3 basically the width of the load from the side. Okay, if you put a 0, 0, 0 for the all box here for D1, D2, and D3, so it's actually represent the whole span. The load, okay, you put at the whole span at the center of the beam. Okay, because D3 is 0, so means that we put the load at the center of the beam. Okay, so now, okay, just key in the value of W1, -10. Direction is in GY, okay, Y direction. And then you can click add. Okay, so here you can see uniform GY -10 kilonewton per meter. Okay. How about the point load? Okay. So for the point load, okay, we have two approaches, okay, to define the point load. Okay, the point load here, okay, can be defined as the concentrated force, okay, as the concentrated force, or as a nodal load. Okay, this is actually a two option, okay, to define the point load. Okay, so if you're using the concentrated force, so this is the concentrated force under member load, okay, you can define the point load, okay, with the distance from the support D1. Okay, however, you must remember that, okay, for the concentrated force, it only can be appear for one span to have one load only. Okay, concentrated force have the limitation, okay, that, okay, it only can appear on the beam, okay, as a one magnitude only. Okay, so if you have one load, one point load at the span AB, okay, then you can use the concentrated force. Unfortunately, for the span AB, we have a multiple point load, 10 kilonewton, 20 kilonewton, and 40 kilonewton. Okay, so this one, okay, will not suitable, okay, for the concentrated force. Okay, so the alternative is actually using the nodal load. Okay, using the nodal load. Okay, however, for the nodal load, okay, so to create, okay, the nodal load, okay, the load must be located at the node. That's why the name is a nodal load. Okay, in order to create the nodal load, okay, the load must be located at the node. Okay, but okay, in our model here, see, okay, we have no node, okay, to accommodate the point load 10 kilonewton, 20 kilonewton, and 40 kilonewton. Okay, for the node 4, in which that we have the 20 kilonewton, we can use the nodal load because here, node 4, okay, they have a node, okay, at that coordinate. Okay, so for this point load, okay, what we need to do is actually create, okay, the node, okay, in order to have the nodal load. Okay, so how to do, okay, how to create the node, okay, because we already have the beam. Okay, so now we can split the beam. Okay, we can split the beam, okay, according to the, okay, distance of the load from the support or from the load to the load. Okay, So how to insert, okay, additional node on the beam? Okay, so what we need to do now, okay, you can go to the insert node here. Okay, go to the insert node here. Okay, and then, sorry. So first what you need to do is actually select the beam, click the beam, okay, that you are going to create the additional node. Okay, select the beam and then go to the insert node. Okay, go to the insert node. Okay, now you can create the additional node. Okay, so specify the distance. Okay, for this first node, okay, that one will become the node number 5, node number 6, and node number 7. Okay, for the node number 5, okay, the distance is actually from the support 1 meter. Okay, so we just put distance 1 meter. Okay, and then click at new node. Okay, click at new node and then click OK. See, we have the new node, okay, for the node number 5. Okay, now we can, okay, create another additional node. Okay, select the beam first, go back to the insert node. Okay, specify the distance. So the distance, okay, for node number 6, okay, is a measure from the node number 5, 2 meter. Okay, 2 meter. Okay, so put the distance 2 meter. At new node, click at the new node and then click OK. Okay, now we have the node number 6. Okay, similarly for the node number 7, okay, just click the beam, go to the insert node, specify the distance. It's a 2 meter. Okay, click at new node and then OK. So now we have the, okay, nodes 5, 6, and 7. Okay, that, okay, we're going to use, okay, to define the point load. Okay, so we must go back to the load case detail. Okay, click again, load case detail, add. Okay, now we can go to the nodal load. Okay, put the value in Fy, Y direction. Okay, so we have negative 10. Okay, negative 10, add, and then replace with the negative 20. Okay, negative 20. That's a click add, and then the last point load is a negative 40. Okay, this 20 is similar 20. Okay, just a define one time only. Okay, the last one is a negative 40. Okay, negative 40. Okay, add and close. Okay, now, okay, you can see here, okay, at the load and definition, at the working area, okay, you can see here, okay, they have 5 loads. Okay, we have the safe weight, we have the uniform distributed load, negative 10 kilonewton per meter. We have the point load, negative 10 kilonewton, another point load, negative 20 kilonewton, and another point load, negative 40 kilonewton. Okay, you can see that they have the question mark here, red color. So this is indicate that the load haven't been assigned on the beam. Okay, what we need to do is actually define the load on the beam. Okay, for the safe weight, okay, click at the safe weight. Okay, you can select the beam and then tick assign to selected beam and then assign. Okay, but the most easy to define the safe weight, actually click the safe weight. No need, okay, no need to select the beam or structure. Okay, just click at the safe weight and then tick at the assign to view. Okay, so this one will be assign the safe weight to the whole structure on model. Okay, so add sign to view and then click add sign. Yes, so you can see that, okay, the beam, okay, will be highlighted with the red color, okay, indicating that, okay, the safe weight already been defined on the beam. Okay, you can see now safe weight from the question mark, okay, change to the another icon. Okay, so and then after that, okay, we can move to the uniform distribution load. Okay, uniform distribution load, just click the load first and then select the beam. Okay, the beam actually from node 2 to 3 and 3 to 4. Okay, you can just click, press the control, your keyboard, okay, and then select these two beam. Okay, and then make sure that tick at the add sign to selected beam and then add sign. Okay, they have the uniform distribution load now. Okay, now we can define the load 10 kilonewton at node 5, right? Node 5 is a 10 kilonewton. Okay, select the load first and then change the cursor to the node cursor because we are selecting the node now. Okay, select node number 5 and then click at add sign to selected node and then add sign. Okay, so proceed with the point load 20 kilonewton. So we have the two node, okay, that have a similar magnitudes of the 20 kilonewton. This is a node 6 and node 4. Okay, we are selecting, we are selecting both node. Okay, and then add sign, make sure we, okay, make sure we click at the load first, and then after that, click or select the node, and then tick at the add sign to selected node, and then click add sign. Okay, so now it's a represent 20 kilonewton. And the last node, the last point load, 40 kilonewton, located at node 7. Okay, we just click this point load and then select node 7 and then tick add sign to selected node and add sign. Okay, this is actually our load configuration. Okay, you can see, okay, here, okay, it's very difficult because the magnitude they have a different magnitude. Some have the bigger value, some have the less value. So how to arrange or to optimize, okay, the diagram of our beam? Okay, you just need to click at the load. See here, this is a load. They have the icon here, okay, known as load. If you click here, okay, it will be automatically optimize, okay, the configurations of the load on the beam here. Okay, so you can actually provide, okay, the value as well. Okay, just click at the symbol and load. Okay, tick at the load value here. Okay, tick at the load value and then apply and click OK. Okay, so now, okay, here, if you can see that, okay, I have made a mistake because I put the two value of the load here, so I need to delete, okay, at the 1. Okay, so I'm the okay, if you want to editing, okay, edit the here. If you can see that I put the load negative 40 and another negative 40 at the node 4 and 6. Okay, so how to delete, okay, this node, because it should be only have the negative 20. Okay, you can just edit, okay, here. Okay, go to the point load negative 40 kilonewton, edit. Okay, and then just untick, okay, 6, yeah, 6 and 4. Okay, change, close. Okay, so now here you can see that, okay, at the load, at the node 5, we have the point load 10, 6 point load, negative 20. At node 7, we have only a point load, negative 40. Span 2, 3 and 3, 4, we have the uniform distributed load, negative 10 kilonewton. And then at the node number 4, we have the point load, negative 20 kilonewton. Okay, so this is actually same, okay, with this our structural configuration. Okay, so we have done everything in the general, okay, starting from the property, spec, support, load and definition. Meanwhile, for the material, okay, you no need to create the material because they have already a concrete here. Okay, concrete is already here, and the compressor strength, okay, is also already specified as the 27 megapascal. This is actually similar what have been provided in the default value of the library, STAAD.Pro library. Otherwise, that you can just edit. Okay, you can edit the value here. Okay, or you can edit the value at the STAAD editor. So it's much easy. So you can see here, okay, at the STAAD editor, okay, so the value of the Young modulus Poisson ratio, density, strength of the concrete, you can just simply edit here, okay, and then save, and then close the STAAD editor. Okay, if you want to change, okay, the material properties, okay, for the concrete. Okay, so we have done everything. Okay, this is the pre-processing. Okay, from the geometry, create the structure, and then we go to the general, in which that we define the property, specification, support, load and definition, and material. Okay, now, okay, we can start, okay, to analyze the structure. Okay, what we need to do now, okay, go to the analyze print. Okay, here, analyze print. Okay, so the analysis print command will be appear. Okay, you can see here they have a lot type of the analysis. Okay, just a general analysis or perform analysis. We have the P delta, we have the cable analysis, we have the direct analysis, flow spectrum, nonlinear analysis, imperfection analysis, buckling analysis, and pushover analysis. So it's a depend on the types of the analysis for our structure. Okay, we must select, okay, the command, okay, for the analysis. Okay, for the basic analysis, we just select perform analysis, and under the print option, okay, this one you can select, okay, any data that you want to STAAD.Pro print or provide for you. Okay, like load data, static check, the static load, mode shape, or you want to all these kinds of the data, you can just tick where appropriate for you. Okay, but in this case, I just leave it as a no print. Okay, click add and then click close. So you can see here, okay, you can see here at the analysis whole structure, okay, they have the command for the perform analysis. Okay, so now, okay, we can start, okay, to conduct the analysis. Okay, just, okay, click at any point here at the interface of the STAAD.Pro, you just click, okay, go to the analyze, okay, and then run analysis, save, okay, and then, okay, the STAAD.Pro will be start conduct the analysis. Okay, you can see here, okay, is already finished, okay, within 1 second. Okay, within 1 second, okay, this beam already be analyzed. Okay, make sure they have no error. Okay, if you have the error, so means that, okay, the structure have not been analyzed. You must go back to your modeling, check the error. Somehow that you miss few data or few step. Okay, I realized that many students, okay, somehow either missing the property or missing the material of the structure. Okay, they are not defined that properties. Okay, if they have the error, you must go back to your modeling, check your modeling, okay, and correcting the model or modify the model, okay, and then run the analysis again. But in this case, we have no error, but we have two warning, right, and then two note. Okay, the warning here is okay. Okay, you can just ignore the warning. Okay, but if you want to know what is actually the warning happen on our model, we can go to the STAAD.Pro output. Okay, here we have the STAAD.Pro output. Okay, now we can check the warning. Okay, so this is the warning. It indicate that, okay, they have the joint instability at the node number 7. Okay, here this node, okay, because, okay, our support, okay, is a roller, okay, it's not a proper support for the beam. So unfortunately, our beam, okay, experience instability. Okay, but this is okay. It's just a warning for you. Okay, you can just proceed to the analysis. Okay, you can go to the post processing to see the result, or otherwise, if you want to modify the model, okay, to avoid the warning, so you can just simply change the support roller to the pin. This is actually a proper support, okay, for our for the real structure of the beam. Okay, so we have done the analysis. Okay, they have no error, and then we can go to the post processing. Okay, post processing. Okay, to see the result. Okay, just click OK, and it will bring you, okay, to the post processing interface. Previously, we are in the modeling. Okay, this one is a modeling. Okay, now we go to the post processing. Okay, so here at the post processing, okay, at the post processing, okay, okay, at the post processing, you can see the result. Okay, you want to see the reaction force, you just click the reaction force. It will give you the reaction force. Okay, let's recheck our reaction force with the, okay, that being calculated. Okay, that being calculated in the, okay, in the this module. Okay, you get this one, 19.88, 62.9, and 67.32. Okay, somehow that we get here slightly different. Okay, we get higher. Okay, 28.653. We have the 83 and 84.48, 80.48. Okay, for the reaction force. Okay, so the reason why they have the so much differences between the value here, okay, but not too much basically. Okay, not too much the differences, because the method that we use, okay, to conduct the analysis. Okay, in this case, okay, the analysis using a moment distribution method. Okay, moment distribution method. So the accuracy of the moment distribution method depend on your step or iterations of the calculation. Okay, somehow if you stop, okay, at the early stage, so that the value will be smaller. Okay, so for the final element, so this is actually much more accurate compared to the moment distribution method. Okay, if you if you are slightly continue the analysis, okay, using moment distribution method, perhaps that you will be end up to have a similar value with what that we obtain from the STAAD.Pro, okay, using a finite element method here. Okay, so you can enlarge the interface. Okay, you want to see the displacement. Okay, this is the deflection. Okay, it's actually quite small in terms of the diagram. Okay, we can actually just scale. Okay, the scale for the displacement here. Okay, so we should have the smaller value of the scale. Okay, let's see 10. Okay, if you click, then you can see the deflections of the beam. Okay, so if you want to see the value of the deflection, okay, you can either check the displacement here. Okay, you can check the value here at the maximum, okay, maximum displacement. Okay, the value of the displacement here, you can check from the table here, or you can go to the result. You can go to the result, go to the view value. Okay, go to the beam result, and and then you can get you can just tick the maximum resultant. Okay, then you can have the value of the deflection. Okay, another alternative. Okay, you can just double click. Okay, you just double click the span. Okay, here you can also get the value of the deflection. Okay, given to you. Okay, the distance for the span. Okay, node 2 to 3. Okay, the maximum displacement here you can see is a 1.66. Okay, you can just play around here. Okay, for the y direction, you must select the directions of the y. You can actually found that the maximum displacement occur here at the 2 meter from support 2 at the center of this span with value 0.938 mm. Okay, so this is actually the displacement. What else that you need to know? Okay, how about the bending moment and shear force? Okay, for the bending moment and shear force, we go to the beam. Okay, so if you enlarge this interface, so this is actually the bending moment. See here, you can select the deflection, bending moment, and shear force. Shear force. So this is a bending moment. So this is the bending moment diagram. If you want to show the value, go to the result, view value. And then let's see, we are show the value at the mid span. So this is actually the value of bending moment. If you see the bending moment diagram from the moment distribution method, so basically it's the same. It's the same. Here at the center, you got the value 36.64, but here, around 40.238 kilonewton per meter. So here, at the span 2-3, the bending moment have a 27. But here you get a 22.68. You can see that for the bending moment, the value is actually 30.72. Here we get a slightly No, this one is not at the support. If you want to see at the support, okay, you change the value. Okay, you can get, I think at the end, I believe. Okay, so here at the support, okay, here is a 41 kilonewton meter. Okay, based on the calculation, you get a 30.72. Okay, so only 10 kilonewton meter differences. Okay, so this is actually for the bending moment. And for the shear force, okay, so this is a shear force diagram, same, right? Okay, this one much more better because the reduction of the shear force, okay, dependent on the element of the beam. Okay, so here we can see that the reductions of the shear force is almost constant, okay, for every single actions of the load. Okay, but have no much different, okay, between the moment distribution method and STAAD.Pro. Okay, you can see the result. Okay, just go to the value and then activate, okay, at the maximum as an example. Okay, you can get the value of the maximum displacement. So otherwise, okay, you can go to the graph. Okay, you can go to the graph. You can just click at the span, every single span here. Okay, automatically you can see the value and diagram of the bending moment represented by MZ, and also the shear force represented by Fy. Okay, here. Okay, at the span 2, 3. So this is actually the bending moment and shear force. Okay, and you can also just double click the beam. Okay, you can see the bending moment. Okay, so this is the bending moment. Okay, or you want to see this is actually much more detailed. Okay, the value of the shear force at the every single distance. Okay, from the support, you can see the value of the shear force and bending moment. Okay, if you just move, okay, this distance from left to the right. Okay, what else you want to see? Okay, we have the result stresses. Okay, if you want to see the stresses, so this is the result of stresses. Okay, and you want to see the value of the stress. Okay, you can check here the value of the stress. Okay. Okay, what else that you want to see? That basically, okay, you can see the displacement, reaction force, okay, at the node, okay, and then at the span of the beam, you can see the force, okay, in terms of the bending moment, shear, torsional, okay, and then you also can have the data about the stresses, okay, if you want to have the, if you want to analyze the stress on the beam, okay, this one also can be represented by the graph, if you want to see the graph of the bending moment and shear force. Okay, if you want to see the animation, okay, you can also create the animation in terms of deflection. Okay, just click apply and okay. Okay, you can see, so this is actually the animation, okay, that happened, okay, under the influence of the load. You can see that, okay, both at the point load here and the cantilever have the obvious movement or deflection of the beam. Okay, that need to be take a necessary consideration in terms of the design later on. Okay, so this is actually all about the case study 1. Okay, any question regarding this problem? Are you okay with the case study 1? Okay, so far tak ada. Okay, but actually, if you miss, if you miss the steps of the modeling, you can just check with, you can go back to my note, this note, go back to the note, here you can actually follow the procedure step by step later on,
Doctor, sorry to
Yeah.
interrupt again. Just to remind you that for session B, for part B, there is still left 50 minutes.
Okay. We basically finish at 5, right?
Yeah,
Mr.
according to
Jimin?
the
Schedule. Okay. So I think maybe part C, we may not include in this this afternoon session, because we have only around 45 minutes, and we should actually proceed with the case study 2. Okay, so the case study 2 is essentially about the indeterminate truss system. Okay, so this is actually our truss system. Okay, we have the joint A, B, C, D, E, F, G, and H, in which that the truss is subjected to the point load 30 kilonewton at joint H and F, and another point load at joint 40 kilonewton at joint D. Okay, this is another point load 40 kilonewton at joint D. Okay, so the size of the truss is actually a steel truss system. Okay, for the top chord, so this is a top chord. Okay, for the top chord and bottom chord, so this is a top chord and bottom chord. Okay, so we have the size SHS, which is actually represents square hollow section, 60 times 60 times 4. Okay, and then for the web, okay, so this is our web. Okay, the blue color represent a web member, or somehow we call as the internal member of truss. Okay, the size is a RHS, rectangular hollow section, 60 times 40 times 3.6. So this is actually a steel. Okay, steel section. Okay. So so for this model, the strategies to model the truss, basically what we need to do, we decide the joint A will be our reference node. Reference node will become node number 1 with coordinate 0, 0, 0. Okay, so then we copy node 1 to create node number 2 at joint E. Okay, and then after that, we're going to connecting the node, and then insert or create additional node, represent node H as a node number 3, G as a node number 4, and F as node number 5. Okay, so this is actually the most easy method to create the node for our truss member. And then after that, we copy node 3, 4, and 5, so that here we can copy and paste to create node 6, 7, and 8. Okay, so this is our strategies to model the truss in STAAD.Pro. So basically they have a lot, the lot strategies that you can use. I will show later on, if you want to use the repeat function, how to use the repeat function. I think I want to show you using the repeat function. Okay, so if we're using the repeat, repeat function, we just create the node number 1, and then after that we repeat node number 1 for the few times, few times, so that we can get the rest of the node at the bottom chord. And then after that okay, we can copy, okay, the node at the bottom chord to create the node for the top chord. Okay, so this is actually that I'm going to show you, okay, using repeat function. Okay, you have learned about the copy and paste, also the insert or create the additional node using insert node. Okay, so this is actually the function that you can utilize, okay, for your strategies, okay, to construct the model on STAAD.Pro. Okay, so I will save, okay, my model, okay, and start with the new one. Okay, space, okay, this is a case study 2. Okay, next, finish. So now we have the new interface for our case study 2. Okay. Okay, so first what we need to do is create the reference coordinate. This is actually node number 1 as a 0, 0, 0. Okay, you just put 0 and enter. So this is our first node. Okay, so we can activate the number of nodes. Okay, you just go to the symbol and level. Okay, tick node number and node point, and then click OK. So that you have the node number 1. Okay, so if you want to use the repeat function to create the node number, the rest of the node at the bottom chord, because the distance is the same, okay, every 3 meter, okay, so it's actually just easy, okay, to use the repeat function. Okay, so how to use the repeat function? First, we need to select the node number 1, and then go to the translational repeat. Okay, we have the translational repeat, we have the secular repeat. If you want to repeat in the secular, okay, to create the secular shape object, you can use the secular repeat. For the translational, okay, so it's actually in the single direction, either X, Y, or Z. Okay, we click at the translational repeat. Okay, we want to repeat in the X direction. So how many steps that you want to repeat? So we want to repeat 1, 2, 3, 4, 4 times. Okay, we want to repeat 4 times, so that, okay, we put number of step 4, and then after that, okay, and then after that specify the distance. This is actually 3 meter. Okay, 3 meter. Okay, so here if you click OK, so now, okay, it provide you with the, okay, a complete set of node at the bottom chord. So we can now rearrange our, okay, okay, so here is a node number 2, 3, 4, and 5. Okay, now we copy node number 2, 3, and 4, or you can just use a translation repeat. Okay, if you want to use a translation repeat, okay, select node number 2, 3, and 4. Again, go back to the translation repeat. Okay, in Y direction. Now it's in Y direction. Number of step, just one step, and the distance is 2.4. Okay, 2.4. And then click OK. So now you have the complete set of node for the top chord. Okay, we go to the view from Z. Okay, so now we can create the element of the truss using add beam. Okay, add beam. Okay, so remember, when you create the element, make sure that you create from a single direction, from either all left to right, or top to bottom, or bottom to top. Okay, don't mix with the left to right, right to left, because it just make the calculation on finite element method become difficult. Okay, it make that the process of the analysis take a longer time. Okay, so always, okay, create the element from a similar direction using either left to right, right to left, okay, or from uh, bottom to top or top to bottom. Okay, so here, okay, we create the top and bottom chord first, okay, from left to right. Okay, okay, and then we have uh, the web. Okay, okay, so now we have the complete geometry, okay, for our truss system. Okay, we move to the general. Okay, we move to the general. Okay, so under property, okay, we must define the size of the truss and also the material. Okay, the material is a steel. The size is actually depend for the top chord and bottom chord. We have the SSH 60 times 60 times 4. And for the web, we have the RSH 60 times 40 times 6. Okay, so how to define the size for the steel truss? Okay, at the property, go to the section database. Okay, go to the section database. Okay, so somehow it will take a longer time because this the section database basically a complete sets of the library. Okay, so they have a lot of data here. Okay, it's actually take a time to generate, okay, the section database here. Okay, so under steel, okay, here you can see that the section profile table, we have the steel, cool form, steel, timber, and aluminium. Okay, we are using a steel, which is a hot roll. Okay, we go to the British. Okay, we go to the British, and then we go to the tube. Okay, so if you go to the European, okay, if you go to the European, okay, you can get also tube here. Okay, same. Okay, European, okay, and British, okay, using a similar code of practice. Okay, BSEN. So doesn't matter you want to use British or European. So this is our reference, okay, for the steel section. Okay, but I prefer to use a British. Okay, so we go to the tube. Okay, here you need to find for the SSH, okay, 60 times 60 times 4. But for the tube, okay, the code basically is a TUB. Okay, represent tube. Okay, but you must find the appropriate size, 60 times 60 times 4. Okay, 60 times 60 times 4. So this one is a 60 times 60 times 3. Okay. Okay, now we have here 60 times 60 times 4. Add. Okay, and then we find another size, 60 times 40 times 3.6. Okay, 60 times 40 times 3.6. Oops. Here, right? I know. Here. Here, right? Okay, 60 times 40 times 3.6. So add and close. Okay, here you can see that we have two different sizes. Okay, we have the tube 60 times 60 times 4 represent reference 1 or R1. For the tube 60 times 40 times 3.6, it will be represent R2. Okay, so how to define the size on the truss? Okay, first we need to, okay, click, okay, for the size 60 times 60 times 4. Okay, and then we are selecting the member of the truss for the top chord and bottom chord. Okay, and then assign to selected beam and then click assign. Okay, you can see that R1, okay, already marked, okay, on the related member. Okay, for the web or internal member of the truss, okay, we select all, okay, member of the webs, okay, and then assign to selected beam and then click assign and click yes. Okay, now you can see that, okay, the all member, okay, either been assigned as the R1 or R2, okay, which is actually represent the size R1 for the SHS, okay, 60 times 60 times 4. Meanwhile, for the R2 represent RSH, okay, 60 times 40 times 3.6. Okay. For the truss, okay, we need to define the internal member with the partial moment release. Okay, this is actually a specific requirement. Okay, for the truss, okay, you need to go to the spec. Okay, go to the spec and then go to the beam. Okay, here, okay, we define a release, okay, on the web members. Okay, so release have a two location that we need to release at the start location and at the end location. And then we have the two different release type, either to use a partial moment release or to use a release. Okay, so this is up to the requirement, okay, decided by the designer or the structure engineer itself. Okay, in this case, we are using a partial moment release. It's just a simple, okay, it's the most convenient, okay, for our truss system. Okay, and then we take the value of the MP for the partial moment release and define the value as the 0.98. Okay, so this is the coefficient, okay, that generally being used, okay, to define the partial moment release of the truss system. Okay, and then just click add. So this is a start. Okay, we must repeat the same procedure for the end release. Okay, 0.98. Here, 0.98. Okay, close. Okay, so we have a release, okay, on the web, okay, for started and end. So what we need to do is actually select, okay, select the web, okay, and then first you need to click at the start, select the web, okay, make sure that you tick assign to selected beam, then click assign and yes, and then, okay, select the end, okay, then assign yes. Okay, you can find here, okay, they have a cycle mark, okay, at the member of the web, okay, for the start and end. So how we know which one start, which one end? So in order to understand, okay, the locations of the start and end, or to identify the location, okay, what you need to do, go to the symbol and level, and then tick at the beam end. Okay, the green color represents start, blue color represent end. Okay, okay, and apply. So again, okay, green start, blue end. Okay, you can see that. Okay, so this is actually the start and end release. Okay, for our web member. Okay, so this is actually the specification that you need to define for the truss system. Okay, for the support, okay, same, we have a two support, pin and roller, okay, similar as the previous model. Okay, for the pin, okay, you just define pin, and for the roller, you need to use fixed butt, okay, but you must tick all except FY. Okay, add and close. Now you can define the support on the truss. Okay, for the node 1, sorry, node 1. Okay, for the node number 1, we have the pin. Okay. And then for the node number 3 and number 5, okay, we have roller. Okay, so this is actually not the support system is not really a practical for the truss system. Okay, you can see later on that okay, the system of the truss will be experience instability. Okay, because we have the roller here. But because this one I took the sample of the truss, okay, from the structure analysis module example 3.3. Okay, so this example. Okay, so this example basically the distance actually not practical, 30 meter. This is actually something wrong here for this example. So what I'm used actually just a 3 meter. Okay, 3 meter of the 3 meter. Okay, 3 meter. Okay, for the distance every single node of the truss, and the height of the truss is just 4.2 instead of the 24 meter. Okay. Okay, we have done with the support system. Now we move to the load and definitions. Okay, the procedure is same. Okay, at the load case, okay, we define okay the load type is none, and the title just use as the load case 1, add and close. And then under load case 1, click add, and we can define first save wake. Okay, add, and then we go to the nodal load. Okay, here, okay, so all point load, okay, will be located at the node, okay, node 2, 4, and 8. So we can just simply use the nodal load. Okay, we must define negative 30 kilonewton and negative 40 kilonewton. Okay, we define a negative 30 kilonewton at and another point load negative 40 kilonewton for FY. Okay, add and close. Okay, for the save wake, again, the most easy, okay, to define the save wake, just click the save wake, go to the add sign to view. Otherwise, you must select the structure. Okay, but because all whole structure must be defined with the save wake, okay, the simple way is actually just select the save wake, go to the add sign to the view, then just click add sign, then yes. Okay, for the point load 30 kilonewton, okay, it will be located at the node 2 and node 4. Okay, so we must change to the node cursor. Okay, select node 2 and node 4. Okay, tick add sign to selected node, add sign, and yes. Okay, and then the last node is the last load is a negative 40 at the node 8. Okay, so this node. Okay, add sign to selected node, add sign, and yes. Okay, so you can see that it's actually quite difficult to identify the load. What you need to do actually just click at the load. Okay, so here, okay, we deactivate the beam release, beam end. Okay, you can see here. Okay, if you tick the save wake, it will be highlight all the member. If you click the 30 kilonewton, okay, you can see that, okay, this two load will be colored by blue color. If you click at the 40, okay, you can see that the 40 kilonewton at the node number 8 will be highlighted or colored by blue. Okay, so this is actually how you know which node, which load that been selected. Okay, based on this function. Okay, you want to actually make the value of the load appear. Okay, on the interface, just go to the symbol and labels, and then tick the load value. Now you can get here 30 kilonewton, 30 kilonewton, and 40 kilonewton. Okay, we have done everything. Okay, in terms of material, you can check that we use the steel. Okay, so basically come from this material steel. Okay, here. Okay, so we can proceed with the analysis, but before that, we must define the command analysis and print. Okay, click at the analysis and print. Okay, nothing to do here. Okay, we just select the perform analysis. You can use the no print, add and close. Okay, and run analysis. Okay, you can see here. Okay, within 1 second. Okay, the analysis is completed. Okay, you can see that they have no error, so means that our model is correct. They have a one warning. I believe the warning because of the instability due to the roller support. Okay, you can check here. Okay, go to the stat output. Okay, then you can see here they have the instability at the joint number 3. Okay, joint number 3 is here. So because it's a roller, okay, and they have the more than one member, okay, at this joint, which is actually have the large degree of freedom. So of course, you will create the instability, okay, at this node number 3. Okay, but this is okay. It's just a warning for you. Okay, you can proceed, okay, to modify. Okay, as an engineer, you have the opportunity or you have the option either to proceed to modify, okay, the truss, or just ignore the warning. Okay. Now we can go to the post-processing, okay, to see the result in terms of displacement. Okay, you want to see the result of displacement. Okay. Okay, we can go. Okay, we can scale the displacement here. Okay, like 50. Okay, okay, it's just a the displacement is actually not really obvious. Okay, you can change the scale to the 10. Sorry, 10. Yeah, you can see this is actually the displacement pattern of your truss. Okay, you can see either the truss is stable or not. How to know that the truss is stable? You can check the animation. Okay, here you can see. So based on this animation, you can observe the mode deflection of the truss. Okay, here you can see that, okay, the truss have a few different mode, which is actually move in the vertical direction and also move in the horizontal direction. Okay, indicating that, okay, the truss is not really stable, okay, because of the support that you use. Okay, so here as an engineer, you must really make a good decision, okay, to provide, okay, the boundary conditions on your truss system. Okay, and then you also can see the reaction force. So this is the reaction force. Okay, you have the I believe that the reaction force is actually a different, okay, with the this one, because the because of the length and height of the truss. Okay, here you can see that we have the 40 and 60. Sorry, this one is not the final one. Okay, so this one should be the final one. Okay, we have a 12, 32, and 56. Okay, so here you have the, okay, so okay, you can, okay, move this one to here and to here. Okay, you can see we have the 11 here. So this one 12, almost close. We have the 60. Okay, this one is a 56, almost close. And this one 31. And this one is a 32, almost close. Okay, how about the internal forces? Okay, how about the internal forces? Okay, in order to know the internal forces, you can go to the beam. Okay, go to the beam. At the force here, you can check under maximum axial force. Okay, under maximum axial force. So you can see here the value of the Fx represent the axial force. Negative is the compression, positive is the tension, represent tension. Okay, you can see here, okay, these members, this member, okay, experience tension, okay, with the internal force 31.39 kilonewton. Okay, you can check one by one. Okay, for member one, so this is member one, experience compression. So here member one also experience, this one experience tension. Okay, sorry, yeah. So in STAAD.Pro, okay, for the axial force, negative represent tension, positive represent compression. It's actually a contradict, okay, with the theoretical. Okay, in theoretical, okay, negative is compression, but in STAAD.Pro, okay, negative will be represent tension. Okay, so for beam one here, so this beam, okay, experience tension because it's negative. So here, okay, the member for the member one here also represent tension. Okay, the value is a 15. Okay, but here the value is a 13, almost close. Member two also tension. Okay, member two also tension. Okay, see here, okay, for the member CG, okay, have a 0 internal forces, but here member, here this member, okay, so this member is a member number 10. Okay, you can see a member number 10. Okay, for member number 10, okay, you can see that, okay, they have a small fraction of the internal forces, 0.426. Okay, not 0. Okay, here you get a 0. Okay, but this one you found that, okay, the internal force occur with just a small fractions of value, 0.426 kilonewton. Okay, so this is how that you will be able to get the internal forces on the truss system. Okay, for the rest, okay, you can see the moment. Okay, moment is not visible because we have no uniform distributed load. All load actually located at the node. Okay, so that the moment, okay, will be very small. Okay, you can check here. Okay, moment. Okay, for the bending moment, you can see that, okay, the value of moment mz is actually just a small value. Okay, because all load is actually located at the node. Okay. Meanwhile, for the uh, shear force, okay, you can have the shear force here. Okay, shear force also have the small value. Okay, we know that for the truss, okay, the most dominant, okay, is actually happen because of the internal forces, or also known as the axial load. Okay, so this is actually for the axial load. Okay, so this is the axial load. Okay, so this is the drawing of the axial load. Axial load represented by Fx. Okay, so this is actually the diagram, axial load diagram on the truss system. Okay, we can scale the value of the axial load. Okay, let's see, we have the 500. Okay, so this one will show a better, okay, better representations of the axial load on the truss. Okay, otherwise you can just simply, okay, click on the member. Okay, you can check at the graph. Okay, at the graph here, you can see that this is the axial load. Mz represent moment. You can see the value is very small. Fy represent the shear force, and Fx represent the axial load or internal forces. Okay, you can check one by one, okay, based on this graph. Okay. Okay. So I think, okay, that's all for the case study number 2. Okay, we already reach 5 o'clock. Okay, I believe that, okay, this afternoon session for the STAAD.Pro workshop, okay, will be end until case study 2. Unfortunately, I will not be able to uh, to share with you, okay, another advanced approach in the structure analysis, what we call as the finite element method. Okay, this finite element method is the most advanced method in the structure analysis. You can use, okay, you can use this kinds of method to analyze the slab or to analyze the single structure like this. Okay, single structure like a section beam, plate, or you have the shear wall. Okay, if you have the shear wall on the building, okay, you want to study the stresses, okay, you can use the finite element method. Okay, but don't worry, they will have actually personally I have another workshop for the finite element method. Later on I will distribute the information through the IEM. You have a free year to join the finite element method workshop. Okay, if you want to study about advanced analysis. Okay, for this example. Okay, this example basically also include in the finite element method workshop using STAAD.Pro. Okay, maybe today, okay, I'm not able to share with you, but if you are really interesting, if you have the interest to study about the finite element method in the advanced structure analysis, you are invited to join my finite element workshop. Okay, later on. Okay, the date will be still not specified. Okay, but if they have the workshop, I will disseminate the information through IEM. So okay, so today, okay, what you have learned during these 3 hours is very limited so-called skill or knowledge on the structural analysis, modeling and analysis. Okay, it's very limited because it's a lot actually you need to learn in order to mastering the STAAD.Pro. So this software is very essential and important to those students who are, especially after you finish the degree, you are looking to join the consultant. Okay, the skill in the STAAD.Pro, this is very important. It's part, I can say it's actually a part of the necessary knowledge and skill, okay, that need to be provided, that need to be equipped by all students in order to join the consultant company. Okay, especially okay related to the structure design and finite element modeling. Okay, for the design, okay, for the design, basically, student in year 3 and year 4, okay, who are study the reinforced concrete design and structural steel design, you have the opportunity to improve your skill in the design using STAAD.Pro if you join the professional training. So this is actually parts of the our focus group, okay, that we try to actually provide the student with the best skill in the STAAD.Pro, okay, so that you are become a more competitive, okay, to seek the career as the structure engineer in the consultant company. Okay, student who are enroll reinforced concrete design, you can actually enroll for the STAAD.Pro professional training in reinforced concrete design. Okay, for student who are join the structural steel design, you can enroll for the STAAD.Pro professional training structure design. Okay, with that, okay, I should end this afternoon session, the STAAD.Pro workshop, organized by IEM student section UTHM. I would like actually to congratulate to all students who are joined the workshop this afternoon, and also for the committee. So my suggestions is that this workshop is actually a best platform, to give exposure to the student in terms of the structure modeling and analysis. Is actually a basic skill in the STAAD.Pro. This is actually very important if you want to join the advanced structure in terms of structure design using STAAD.Pro. You must have a good skill, especially a basic skill in the structure modeling and analysis. I think this is actually a good platform for the all student, to really understand how to conduct the structure modeling and analysis using STAAD.Pro. So thank you very much to all participants and the committee. Now I'm return the session back to the Mr. Chairman. Thank you very much.
All right. So thank you, Engineer Dr. Zainal Rizwan, for sharing so much about STAAD.Pro. It was great to have you here with us today. We hope that our participants found the workshop informative and worthwhile. Our primary goal was to increase your understanding of STAAD.Pro, and we hope that everyone can use the knowledge gained to prepare themselves better in the future. So thank you once again to our honorable speaker, Engineer Dr. Zainal Rizwan. So now we have almost completed today's event. I would like to invite all the participants to turn on your camera for a photo section with our speaker. Multimedia team, please help us to conduct this section.
Hi everyone, I'm Sivarubam Francis from the Multimedia Department, and now we are going to have our photo session. Dear participants, kindly turn on your camera and please smile to light up the session. 1, 2, 3. Once more. 1, 2, 3. Okay, freestyle. 1, 2, 3. Okay, we're done. Thank you for your cooperation.
All right, thank you, multimedia team. So as a reminder to participants, please fill up the attendance form that is provided in the chat box to get your SMAP and e-certificate. Our attendance form will close today at 5:30 p.m. Participants are informed that any requests received later than today at 6 p.m. will not be processed in order to facilitate the ratification. IEMSS UTHM apologies for any inconvenient cause. Thank you, everyone. Thank you, everyone, for taking time out of your busy schedule. Before we end today's section, please follow us on Facebook, Instagram, Telegram, and LinkedIn to keep up to date with the latest announcement and upcoming events. So once again, I would like to show our appreciation to our honorable speaker today for his speech. And also, I would like to show our appreciation to all of the participants today for attending this event today. So you may leave the meeting now and see you at the upcoming events. Thank you and goodbye.